In this video, I introduce pointer networks. Given a training pair, P and C, sequence-to-sequence models compute a conditional probability P using recurrent neural networks with the parameters theta to estimate the conditional probability using probability chain rule, as shown here. Where P is a sequence of n vectors and CP is a sequence of MP indices, each between 1 and n. The model parameters theta are learned by maximizing the conditional probabilities as shown here. The output dictionary size is fixed for all samples Ci and equal to n since the outputs are chosen from the input as shown here. This is a regular sequence-to-sequence model for n equal to 4 and 2D problem as shown here. This encoder and this decoder. Therefore, we need to train a separate model for each n with a fixed dimension. The sequence-to-sequence models we need are able to handle inputs with a different length n. The regular sequence-to-sequence models generate the entire output sequence CP using the fixed context of the encoder RNN at the end of input sequence P, which constrains the amount of information and the computation that flow into the decoder RNN. The attention model can ameliorate the problem by augmenting the encoder and decoder RNNs with additional neural network that use attention mechanism over the entire sequence of encoder RNN states, as shown here. This encoder, this decoder, this attention module. Suppose E and D are hidden states of the encoder and decoder RNNs respectively. The attention vector at each output time I is computed by using these equations. This attention score, this normalization, and this attention. Where UI is attention mask over the inputs, and vector V, W1 and W2 are learnable parameters. The concatenation of DI and DI prime is used for output prediction and fed to the next step as a context. Each output requires performing n operations, so the computational complexity at inference time is O square n. Pointer net combines the attention mechanism into encoder-decoder RNNs to solve combinatorial optimization problems where the output dictionary size depends on number of elements in the input sequence. A regular sequence-to-sequence model uses the softmax distribution over a fixed-sized output dictionary to compute the conditional probability. However, the pointer net models the probability P using the attention mechanism as shown here. And in this figure, this encoder, this decoder, and this the pointer to elements in the input sequence. Where softmax normalizes the vector UI to be output distribution over the dictionary of inputs. Although the encoder states EJ doesn't propagate extra information to the decoder, UJI is used as pointers to the output element and determines the contribution to the outputs. To condition on C I-1 his corresponding P, C, I-1 is used as the input to the decoder. For more details, please check with these references. Thank you. Bye.